guys, let's start with the phase plot. It's simply you have to calculate the phase angle from the general main question. For finding the phase angles or the inclination, we need to write the g of j omega. Firstly, we need to write the g of j omega right here, which is j omega the whole square divided by 1 plus 0.2 j omega into 1 plus 0.02 j omega. This is our this is our question. Okay. So in this, for finding the magnitude plot, we take the value of j omega as 20 for finding the gain, and it should be our magnitude value 20. So in this case, for finding the phase plot, we use the angle, or we use j omega as 90 degree. Okay, 90 degree be the general value of j omega. Okay, and in the case of multiplication, we have to add it firstly. So for j omega the whole square, we need to add the values of 90 plus 90. Instead of multiplication, you have to do the addition. So 90 the whole square means 90 plus 90, which is 180. Okay, the 180 degree. Then how to find the angle g of j omega? Okay, g of, or the phase angle of g of j omega. It's simply the numerator consists of g of j omega the whole square. Its phase angle value is 180 degree. We found out that's 180 degree. Then in the case of denominator, it's in the form of a complex. Complex means x plus iy represents complex. For finding the angle in, I think it's in your school days, like in +1 or +2, you studied to find the inclination of a complex number, that is x plus iy is equal to tan inverse y by x. Yeah, tan inverse y by x. So in the case of 1 plus 0.2 j omega, you need to substitute like tan omega by 1, and in the case of 1 plus 0.02 j omega, you have to find it using tan inverse 0.02 omega by 1. Yeah, now to omega by 1. Then what's the values of omega? You have to assign any numbers from 0.5 to 100. Okay, 0.5 be the lower frequency we assigned or we choose, and the higher value, I choose the higher value as omega h is equal to 100. If you choose the higher value as 80, then you can choose the values omega from the lowest omega L to omega H. Even if it is 80, you can choose up to the value 80. Okay. Here tan inverse 0.2 omega by 1 is 0.2 omega, and tan inverse 0.02 omega by 1 is 0.02 omega. And all these are in the denominator. So you write the equation as angle of g of j omega is equal to 180 degree minus tan inverse 0.2 omega, or I'll write it the downside. You want to write it all these. You can choose the values of omega and substitute these omega values in this equation and found out simply. Here I make a tabular column for omega. Tan inverse first term is 0.2 omega. Then tan inverse 0.02 omega. Then this gonna be phi. Angle of j omega, I take it as phi. Okay, it's phi. Then here I wrote it as phi. 0.5, 1, 5. Don't forget to write the values of corner frequency omega c1, omega c2, omega L, and omega h. Okay. And you want to choose some values in between all these values. Okay. 1, 5, 10, 50, 80, 100. I choose all these. Hey guys, I got out the values. I wrote it here. Then we are going to plot the values. How? Omega versus this phi. this omega versus this phi. Omega is in the graph already there. So we need to assign the values of phi in which side? In the right side. In left side, we take it as the magnitude values. Here we have the phase values. For that, we choose in the right side as the phase angles. As you can see in the right side, the values are 20, 40, 60, 80, 100, 120, 140, 160, 180 because all the angles are lies in between 20 to 180. Then the tabular column, wait, corner frequency 100, I may get the value as 30 degree. And for the corner frequency 50, I get it as 50. Then for 10, I get it as 106. And for 5, it's 130. And for 1, it's 168. And for 0.5 radians per second, it's 174 degree. All those points I marked and joined here. You can see this be the phase plot and this would be our magnitude plot. The question cannot be completed because the second thing in the question is find the value of k as the gain crossover frequency to be 5 radians per second, right? 5 radians per second. The gain at which the frequency to be 5 radians per second is 28 dB, right? At 5 radians per second, the gain obtained is 28 dB. So, we can draw another picture, another magnitude plot for 5 radians per second. It should be like, I'll draw it. Again, mark 28 dB below this magnitude plot. First, you calculate this 28 dB. First, you want to mark 28 dB below this from every point, every 4 points. So, can you see this? This is perfectly the 28 dB below every frequency points. Okay, we can say it be the parallel line of the first magnitude plot we drawn in the first. We drawn for the gains we got it by calculation. Okay. Then using this picture and 28 dB, we can calculate the value of constant k. 8, that is log k is equal to 28 by 20 and it is 0.039. Clear? So we finish the Bode plot completely with magnitude plot and the phase plot. So we will meet you again in another video. Bye bye.